Hello, my name is Ignacy Stępka, and in this video I'll briefly introduce our work on counterfactual explanations with probabilistic guarantees on the robustness to model change. Counterfactual explanations make black box models decisions more understandable and actionable. Let me explain. Imagine you applied for a loan, but your application was declined. In such a case, a counterfactual explanation would suggest what you should improve in your financial profile to receive a favorable outcome. But what if you actually need 3 months to raise your salary by $200? Well, during that time the decision model that the bank uses might change and invalidate your counterfactual. Obviously, we want the counterfactuals to remain valid despite these changes. And this is precisely what we call a robustness to model change. In this work we propose beta RCE, a probabilistic framework that makes counterfactuals robust to model changes. Unlike most existing methods, it accepts any type of the underlying black box model, offers probabilistic guarantees, and it also gives users control over the trade-off between robustness and the cost of the counterfactual. So, how do we achieve this? First, we define sum, a space of admissible model changes, which includes all the changes we expect might happen, for example data shifts or some model retraining. We aim to ensure that counterfactuals will remain valid across all these potential model changes, with at least a set probability threshold. Next, we model robustness using binomial distribution. That is a probability that a counterfactual remains valid for both the original model and any model from sum. To estimate it, we bootstrap sample models from sum and query them about the counterfactual. However, we are also interested in the confidence that the estimated robustness is greater than the desired threshold. That's why we also quantify the confidence by estimating the conjugated beta distribution. Then, we use its CDF to verify if counterfactuals are robust with a given confidence. That was just a high-level idea of our work, and I highly encourage you to see the paper and the website to learn more. Thank you for your attention.